everyone, and welcome to today's video. In this video I'm going to be talking about the shapes of molecules, and this is going to be the first of 2 or possibly even 3 videos that I do on this topic. In today's video we are going to look at the basic principles behind molecule shape, and we're going to look at some of the shapes of molecules that you might come across in level 2. Okay, so this figuring out the shapes of molecules is determined by what's known as the VSEPR, or I always call it VSEPR, model, which stands for Valence Shell Electron Pair Repulsion model. The principles behind this are that pairs of electrons repel each other, and they want to get as far away from each other as they possibly can. And so these electrons will get as far away, these electron pairs will get as far away from each other as they possibly can. And this is going to determine the angle between bonds and the overall shape that the electrons are going to form. Now this can be lone pairs of electrons or bonded pairs of electrons, it doesn't matter. Lone pairs of electrons are located slightly closer to the nucleus than bonded pairs of electrons. This makes sense if you think about it, because bonded pairs of electrons are located between the 2 atoms that are in the bond. So because the lone pairs are slightly closer to the nucleus, they're going to have a slightly greater level of repulsion than the bonded pairs. Now that's not hugely important at this level, but it will become important at university in particular. So I just want to give you the basic ideas so that you're not caught out by something later. So we have the number of pairs of electrons around that central atom, which is going to determine the shape of that nucleus. The shape of the electrons around that atom. And then you have the number of bonds, and those bonds will determine the overall shape of the molecule. So there are 2 parts to it. Okay, now this makes far more sense when you see it in a model. Let me show you. Okay, so the simplest possible model is where you have 2 pairs of electrons around a central atom. Well, actually no, that's not true. The simplest molecule is where you have only 2 atoms joined together. And if you only have 2 atoms joined together, whether they're joined together by a double bond, a single bond, or a triple bond, they're only ever going to form a linear shape. Okay, so we've only got 2 atoms, then it's very simple. As soon as you get 3 or more atoms, it becomes slightly more complicated. So if we start off with 2 pairs of electrons, 2 bonds around our central atom, then we end up with what we call a linear shape. Okay, the bond angles, the angle from one atom or one bond to the next bond, is 180 degrees. It is linear. They are as far apart from each other as possible. And it doesn't matter whether we've got a double bond and a single bond, 2 double bonds, a single bond and a triple bond, which is what you might get in something like hydrogen cyanide. Doesn't matter. If you have only 2 pairs of electrons around that central atom, your shape is always going to be linear. Okay, 180 degree bond angles between the 2 bonds, right? Okay, so that's the easy one. Now, if we have 3 pairs of electrons, okay, the shape that we get is known as a trigonal. That's T-R-I-G-O-N-A-L, trigonal planar shape. It's called planar because if you look at it from the right angle, you can see that it's on a flat plane. Hopefully you can see that there. Okay, so all 3 bonds are in the same plane. The angle between the 3 bonds is 120 degrees. Now, if all 3 of those regions are bonded pairs, then the shape of the molecule is also known as trigonal planar. And it doesn't matter, again, whether those are single bonds or double bonds. So this would be the shape that you'd have for a molecule such as ethanol, H2CO, I think it is. And we can see down here, the molecule is trigonal planar, and the electrons are arranged in a trigonal planar way as well. Okay, however, if we have one lone pair of electrons. So one region, so you've got two bonded regions, one lone pair, then the electrons are still arranged in that trigonal planar way. They still have that 120-degree bond angle. But the shape of the molecule, as you might see down in this bottom left-hand corner, is now described as being bent. Okay? Sometimes it's known as V-shaped. If I turn it like this, hopefully you can see the V shape. Boom, 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 boom. Bond angle hasn't changed because we've still got three regions of negative charge around that central atom. Okay? Doesn't matter whether we've got single bonds, whether we've got a double bond and a single bond. That's really common. Sulfur dioxide forms that kind of form. The bond angle is about 120 degrees. We've got that lone pair of electrons. Okay, so three pairs of electrons, or three regions of negative charge, I should say. We can either have a bent shape, or we can have a trigonal planar shape. Okay, either of those, whether you've got a lone pair of electrons or no lone pairs of electrons, doesn't matter which way it goes, that bond angle stays the same. Now, where it gets interesting is when we add a fourth pair of electrons in. Now we get a really interesting three-dimensional shape. It's known as a tetrahedron, and the bond angles are 109.5 degrees. So the classic example of this is any methane-derived molecule. So whether you're talking about methane, chloromethane, bromomethane, dichloromethane, dibromomethane, chlorofluoromethane, doesn't matter. If you're derived from a methane molecule and you've got four things attached to it, it's going to be in this tetrahedral shape. 109.5 degree bond angles. These shapes are really cool, and they are the basic shape that carbon forms when it bonds with other things, because carbon typically forms four bonds. Okay, but a lot of things form four bonds, or rather have four regions of negative charge around that central atom. So anytime you've got something that has 8 electrons around the central atom and has no double or triple bonds, then its electrons are going to form this tetrahedral shape. But it may or may not have some lone pairs. So if it has a lone pair of electrons, such as this, bond angle stays the same, okay, 109.5 degrees, but the shape of the molecule now is known as trigonal pyramid. Why trigonal pyramid? Because we have a triangle shape. Okay, so the base here is triangular, 1, 2, and 3. But if I stand it up, it kind of looks like a pyramid, a three-pointed pyramid. Trigonal pyramid. So that lone pair. A classic example for this one is ammonia, NH3. Other examples would be PCl3, PF3, PH3, NCl3, NF3. They all form this trigonal planar shape. Sorry, trigonal pyramid shape. Okay, so that's a really, really common shape. The other option we have is we can put a second lone pair in. So now we've got two lone pairs. The bond angle has not changed, okay? Because we've still got four regions of negative charge around that central atom. Now, I tell a lie slightly there because the bond angle does change slightly. It gets smaller, but how much smaller it gets is totally dependent on what atoms are on there. So at this level, we're going to pretend like the bond angle hasn't changed. And we call this one bent. If you'll remember, we called the other one bent as well. And it becomes a very common exam question for the examiners to ask you to compare two molecules that are both bent in shape but have different bond angles. And what they're looking for at that point is a discussion of how many lone pairs and the geometry of the electrons. So again, this one sometimes is called V-shaped. Again, hopefully you can see the V shape there. We've got two lone pairs. It is a tetrahedral shape, or the electrons, I should say, are arranged in a tetrahedral way. It is purely that the shape is known as bent because we have those two lone pairs. Those lone pairs are still occupying space and they are still repelling the other electrons in the bonded pairs as well. Okay, So how do we go about answering a certain type of question? And these are really common questions that pop up in NCEA. Let's talk about that. Okay, so when it comes down to explaining the shape of a molecule, the process to work through is to talk about first off how many regions of electron density or negative charge are there around the central atom. What is the shape that those electrons form? So in other words, what is the base shape? Then how many bonds and how many lone pairs are there? And what is the final molecule? Now you can talk about the bond angle either when you talk about the shape that the electrons form or the final shape of the molecule, but you should always mention the bond angle. For example, it doesn't matter what molecule we're talking about, but you could say let's pick ammonia for example. The NH3 molecule has 4 regions of negative charge surrounding the central nitrogen atom. Therefore, to maximize repulsion, the electrons will form a tetrahedral shape with bond angles of 109.5. There are 3 bonding regions and 1 lone pair, giving the molecule an overall trigonal pyramid shape. And this general format is one that you can apply to virtually any question. I hope this helps you figure out shape and how to answer shape questions in your exam. In my next video, I'm going to be talking about shapes of molecules with 5 or 6 pairs of electrons around the central atom. Thanks for your time, and I'll see you next. Bye.